doing it after. Okay, here we go. 8.6. Okay, we're going to finish 8.6. Yesterday we worked 8.6, example 1 and example 3. Today we're going to do 4, 5, a little extra, and go back and do example 2. 2's a killer, all right? So just set me up for that one. All right, so let's do example 4. Well, I'll tell you what, before we do example 4, let's just do something kind of off the cuff, okay? Yeah, it won't mess up because it's on the it records what's on the computer, not on that screen. Okay, so what if I had 7 over 2 equals x plus 4 over 2? Spencer, I didn't say work the problem. I just said, what if I had that? Okay? How can I work this problem? Add across? Okay, now listen to me. I don't want you to just guess and check, because could I make the numbers so bad you couldn't guess and check? Yes, I can. Okay? I can make them decimals, fractions, all kinds of crazy numbers. Okay? So, I want to know how you would work this problem, and give me a reason, justify the reason that you would work it that way. Tommy. Okay, Tommy says it's a proportion, and so he would cross multiply. Anybody else? Spencer.
I would subtract 4 from the top of both sides.
Okay, and what's your justification?
Because since they are over the same denominator, you can treat you can just focus on the numerators and treat them as if they're over 1.
That's right. Y'all look, if you have a square over 2 is equal to a triangle over 2, what do you know about the square and the triangle?
They are both over 2.
And so they both have to be equal. What's that sign right there say? They have to be the same, right? So I can just say, hey, x plus 4 has to be 7. So what does x have to be? 3. Okay? Now, what if you didn't see that and you said, oh, I'm cross multiplying, that's a proportion. Then, what is 2 times x plus 4? Tell me what you get. 2x plus 8 is equal to, what's 7 times 2?
14.
Now, how do I solve that? So 2x is equal to 6 divided by 2. Do I get the same answer? Mm-hmm. Yeah, you do. Now, what if somebody else looked over there and they said, hey, I'm going to multiply both sides by 2 and make what happen? That's right, that's what Jody said. And what's going to happen on this thing? It's going to cancel out the 2's, and what are you left with? 7 equals x plus 4. And you get, so look, there's a lot of different ways to work some of these problems, okay? Some of these problems. But now listen, this is the difference between this and this right here. Okay? Some of the kids said, hey, what about a problem like that, Miss Davis? Can I just multiply both of these by 2 and get rid of that denominator? Why?
Because there's no equal sign.
That's exactly right. Y'all, this is different. This is totally different. You cannot get rid of these denominators if you don't have an equal sign or an equation. Okay? Because you can't, it's not like you're doing the same thing to one side as you do to the other side. Alright? You're changing the problem. Is that right?
For these, can you create an equal sign and make one of the fractions negative so that that's what works out?
What do then you're just saying that they equal 0? Is that what someone told you?
No.
Okay. You can't just, you see what I'm saying? That's just the same as me saying, hey, it doesn't have an equal sign, so I'm going to put an equal sign there and then write 1,497. Like, you can't do that. You just made up something. You see what I'm saying? All right. So in this case right here, you just have to collect your, you have to get a common denominator if you didn't have one, and then add them together. Okay? So I'm trying to straighten out something that I have seen happening that's bad. All right? Okay. So let's go back and do example 4 now. Okay. Here's example 4. It looks like this. 1 minus 8 over x minus 5 equals 3 over x. All right. So, what's the first thing you should do?
Make x 1 over 1.
Okay, I'm going to make that plus sign, that minus sign into a plus sign, okay? And then I am going to do what Spencer said. I'm going to put me a line here and make the 1 a 1 over 1. Because most of the time kids like for everything to have a top and a bottom, okay? Now, what I want to show you is, let's pretend that we didn't do this part right here. I want to show you why it's bad. I want to find the least common. Now, this has an equal sign, right? So can I get rid of the denominators?
Yeah.
Yes, I can. And I do that by multiplying by the least common denominator. What's the least common denominator between, I don't have to worry about a 1, guys, x minus 5 and x?
X minus 5 and x.
X times x minus 5. Okay? Watch what happens. That means I'm going to multiply everything by x and x minus 5. Does everybody agree? So I multiply this by x times x minus 5. I multiply this by x times x minus 5. Now, look what's happening to my negative sign right there. Do you see it?
No.
If you multiply this stuff right here, are you going to know that it's a negative 8? Yes or no?
Probably not.
You're not going to, guys. You're writing all over it. Okay? So I'm trying to show you why I want you to do what I've asked you to do. Okay? So I'm going to go back. I'm going to rework the problem. I'm just going to show you. So this was a minus. I told you to go and make it a plus and bring your negative up there. All right. So now I'm going to multiply everything by that common denominator, which you said was x times x minus 5. Now, x times x minus 5. X times x minus 5. Now, do I have to multiply this one times x times x minus 5? Because it's already got an x minus 5 down here. What does the rule say, people? Whatever you do to one, what? You do to everybody. You can't pick and choose. I know what your brain is saying, and they cancel out. But other people won't understand what you're doing. Okay? What you do to one, you do to all of them. So everybody gets multiplied by x times x minus 5. It is over 1. If you want to put that 1, you can. Okay? Now, does anything cancel out here? So, really, what are you left with?
X plus
Which is what?
x squared minus 5x.
Very good. Does anything cancel here? X minus 5 cancel. And what are you left with? Negative 8x. Is everybody okay? All right, anything cancel here? So x's go away. Distribute that 3 and tell me what you get. 3x minus 15. Now I'm going to stop and collect my like terms, okay? Do I have any like terms on the left? What is negative 5x and negative 8x? Negative 13x equals 3x minus 15. Now I'm trying to solve it. It's a quadratic. What's the first thing you have to do to a quadratic to solve it? Very good, because you're trying to set it equal to 0, right? Y'all, you have to set a quadratic equal to 0 before you can solve it. So, I'm going to subtract 3x and add 15. Subtract 3x and add 15. I'm going to always try to keep my x squared or my quadratic term positive. Alright, so whatever I need to do that, that's where I'll move stuff. So this is gone and this is gone, so that's 0. This is x squared. What's a negative 13x and a negative 3x? Negative 16x, and then plus 15. Now, what's the easiest way to solve a quadratic? Factoring. If it doesn't factor, is that it? Yeah, you can use the quadratic formula. Okay? So I'm going to say most of these are going to factor. So x squared factors into x times x. What's a plus sign at the end mean? Same as the first one, so minuses. What are the factors of 15 that add to be 16? Okay. So if 15, x minus 15 is the factor, what's the root?
Just keep one.
Yeah. And x minus 1's the factor, 1's the root. Okay, so now what do we have to do?
Do we have to plot that?
It's not a point. Don't put parentheses around it, people. It's not a point. I have to check and see, okay? So there's two things I'm checking to see. First of all, I'm checking if I get the right answer, right? Because I want to make sure I did the right work. What's the next thing I'm checking for? Extraneous solutions, okay? Now, an extraneous solution in this case with these rational ones is going to be because he probably created a 0 in the denominator. Now, if that happens, am I going to get a different number on this side than I get a different number on this side?
You won't get an answer at all.
You won't get an answer at all. What's he going to say?
Error.
Error. Divide by 0. Very good. Okay, so I want you to understand, if I get a different answer on each side, that's going to kind of make me go, whoa, wait a minute. I need to go back and check that and make sure. Not saying it will never happen. I'm just saying the odds are a lot slimmer of that happening. Okay? So, we checked one, so I'm going to check this one with you. I'm going to show you how to check it. So we're going to take our little calculator, and we're going to plug the two numbers in. What do you want to plug in first, 15 or 1? 15? Okay, so y'all, when you check something, you always go back to the original problem. Don't check with the problem after you messed with it, okay? So it's 1 minus. And you want to use your fraction button. I don't have a fraction button, so I can't use it. If I did, I would use it, okay? No, my calculator's not up to date. It's an old. Okay, what, y'all don't believe me? All right, what did I just say? I don't have a fraction button. And you're like, yeah, you do, Miss Davis. You just go to alpha and y equals.
I believe you, Miss.
It does look the same, but it's not the same, is it? No. All right, so then it is 1 minus, what is it, 8 divided by, I have to use parentheses on the bottom because I'm doing something, 15 minus 5. All right, so that's the left-hand side. Point 2. The right-hand side is 3 over 15, is that right? Point 2. Boom, 15 works. Okay, 15 works. So I like 15. I'd put him in my brace. And then you have to check 1, right? So your easiest thing to do is to arrow back up and capture it. I can't do that. See, watch. Let me show you because you don't believe me anymore. Okay? See, is it going anywhere? No. I have to go second and enter. And then if I want to pull the first one, I'll do second and enter again. And then I'll go back over here and I'll delete that 5. Now it's 1 minus 5. 1 minus 8 over 1 minus 5. 3, and the other one is 3 over 1, and I'm pretty sure that's 3 too. Okay? I don't have to put that in my calculator, people. See, that's why teachers don't like kids giving them calculators, because there's a whole bunch of people, they put that in their calculator. 3 over 1. Crazy. All right.
Just in case some divine intervention comes in and say, PF, that's an error, that's wrong.
No. So both of them are solutions. Okay. Nothing. He's talking. All right. So there's my answer. Anybody got a question? Everybody okay?
We have to put it in the braces.
Yeah, you should put it in the braces. All right. Let's do the next one. This is example 5.
It's going to take a long time.
This one's a little bit longer. He is 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x minus 3. Okay, 10 seconds. Do what you should do, people. Know what you should know. What did you do? No.
You changed the
Yeah.
expression.
I changed that to a plus sign and pulled my negative up here. Now what are we doing, Luke?
Factor.
Now we're factoring. Why are we factoring? We didn't factor on that other problem.
You can. This is the two perfect squares.
But why?
So we can use
If it were on the top, would I factor it?
no.
So why am I factoring this on the bottom?
It makes it easy. So you can find the least common.
So you can find the least common denominator. Y'all, the least common denominator is every factor represent. There you go. Every factor represented, okay, and the most that anybody has. Those were our two rules that we learned. So you can't represent the factors if you don't know what they are. So every denominator has to be fully factored. This is the difference of two perfect squares. What does it factor into?
X plus 3x minus 3.
All right. Now I'm going to draw a line through this denominator because that is no longer my denominator, but this is it. Now, what is the least common denominator between x minus 3, x plus 3x minus 3, and x minus 3?
X plus 3x
Oh,
minus 3.
stop. Everybody stop. I wrote the problem down wrong. This should be a plus right here. Sorry.
I already started going ahead.
Okay.
How do you sound like that?
All right. I'm okay with you working ahead. You just never know what might happen though. All right. So what is my least common denominator?
X plus 3x minus 3.
X plus 3x minus 3. What am I going to do with that?
Put it on the bottom. Multiply it by everything.
Why? Because what's it going to do? It's going to get rid of the denominators, okay? So I'm going to multiply this by x plus 3, x minus 3. Do I have to multiply this side by this one because he already has that as a denominator? Yes, people. That's what I've heard all day. Two people out of the class will pop up and say, hey, you don't have to multiply that one because he's already got that. I'm like, we're not finding a common denominator. We're using a common denominator. Okay? So multiply this one by it. Uh-oh. Sorry. Went crazy. And multiply this one by it. Now, as long as I have an equal sign in my problem, it's legal to multiply everything by the same thing, right? Okay, what happens over here? Who cancels out?
X minus 3.
And you're left with 6 times x plus 3. What is that?
6x plus 18.
Very good. 6x plus 18 equals. What cancels on this term right here? Oh, everything. Pow, 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 zap. I feel like a cartoon. All right, what am I left with?
8x squared.
Oh, 8x squared. What cancels here?
X plus 3.
Gone. Multiply through by, be careful here, be careful, be careful. Anytime I see a negative sticking out there, I go, whoa, you better be careful. Trying to trick you. What do you get?
Negative 4x squared plus 12x.
Very good. Negative 4x squared plus 12x. Any like terms on the left? Any like terms on the right?
Yes.
What are they?
8x squared and negative 4x.
What is 8x squared minus 4x squared?
4x squared.
Now what's my goal? What am I supposed to be doing?
Get all of it on one side.
Yeah, because I'm trying to set it equal to 0, right? So I'm going to subtract 6x and subtract 18. Minus 6x and minus 18. So he's gone and he's gone. I got 0. Over here I have 4x squared. What's 12x minus 6x?
6x.
So plus 6x minus 18. Now, I don't have to do this, but is there anything I could do right here to make my life a little easier?
Factor out.
Yeah. Can I divide both sides by 2? Is that legal? Yeah. As long as what I do to one side, I do to the other side. And I have sides this time because I have what sign? An equal sign, okay? What's 0 over 2?
0.
And divide everything here by 2, and I'll get 2x squared plus 3x minus 9. Now I'm going to factor it. So 2x and x. Minus sign means they're different, plus and minus. let's see, I'm subtracting them, and I'm trying to make a 3. Oh, I'm going to do a 6 and a 3. 6 minus 3 is 3. 3 times 3 is 9. Negative sign. I want a positive 3, so I'll put my plus here and my minus here. All right, so here's my question. This is the factor, okay? What's the root? Positive 3 over 2. Very good. This is the factor. X plus 3 is the factor. What's the root? Negative 3. Now I want you to check them, okay? I'm not checking them. You check them really quick. All right, y'all got it? Okay, did y'all check 3/2? Did it check? Yes? Okay. So my solution is 3/2. Did you check negative 3? Did it check? Why? Very good. It's extraneous. It's a division. It's creating a 0. It'll create one here, and it'll create one here. Okay? I mean, it doesn't matter. If it creates one in any one place, it's going to tell you have an error. So what am I going to do to him to show that he's extraneous? I'm just going to put an X on top of him. Do I put him in my solution set and put an X on him? No. Do I put him in there and then write extraneous beside him? No. Why am I asking you all these crazy questions? Because these are the crazy things that I've seen you do. Okay? So, I'm saying don't do that. If it's not a solution, people, don't put it in a solution set. All right, anybody got a question? Okay, so we have one more problem to do. Y'all listen to me. This is example 2. It is the most difficult word problem type of word problem. Okay? There is one on your test. There is no mistaking. It's not like you're going to look at these and go, whoa, I wonder if that's one of those, like that really hard one that we worked. You're going to look at it and go, oh, crud. That's one like that really hard one that we worked. Okay? No. No. And once we get it set up, you're going to be home free. But setting it up is difficult, okay? And it takes a little bit of understanding. But here's what we're going to do. We're going to write it all out and work it out, and then I want you to go home tonight, and I want you to work it 3 times. The first time you work it, you're going to have to look back at your notes. The second time you work it, you might have to look back at your notes. The third time you work it, You shouldn't have to look back at your notes. And you ought to start being able to connect some dots, okay?
This is going to be a different problem than this one?
Yep, but it'll be just like it. They're all the same.
Okay, I was going to say, are we going to like do this one as fast as I alright, do that one again?
No.
That's what Mr. Morris does. Mr. Morris will be doing a worksheet. He's like, this may show back up on the test, and then he'll put like a 4 instead of a 2 for a number.
So it'll be the same type of problem, but it might deal with something different, okay? Like, well, let's just do the one today, and then we'll talk about what kind of things could you do to it, all right? So we're going to talk about an alloy. What's an alloy?
A combination of two metals.
Right, or more, right? Whenever you put more than one metal together, then that's an alloy. Is pure gold an alloy? No, it's pure gold. My wedding band is gold. Is it pure gold? No. If it was, what? It would bend all up. It would mar. It wouldn't look pretty anymore. Okay? Pure gold is really malleable, so they put other stuff in it, right? To make it hold its shape and be shiny and pretty and not get scratched up and things. Okay. So here's what we're talking about today. An alloy is formed by mixing 2 or more metals. Sterling silver is an alloy. Okay? So we're going to talk about sterling silver. Now, do y'all know what sterling silver is?
It's sterling and silver.
Okay. Most of this sterling silver that they're talking about, have you ever seen the sterling silver place settings, like silverware and stuff? Fancy restaurants. Maybe your grandmother has some. Maybe your mom, and I doubt y'all are too young for your parents to probably have it. But your grandparents might. Okay? It's really like a place setting, which is just a nice, probably 2 forks, salad fork and dinner fork, and a spoon. It probably costs hundreds of dollars. I mean, it's really expensive. So people don't really have it like they used to have it. You only get it out probably at Christmas and Thanksgiving, Easter, something special occasions, okay? Sterling silver is an alloy. It is composed of 92.5% silver plus 7.5% copper. It tarnishes really easy, okay? You might have seen people polishing their silverware or their teapot or something like that. Okay, it tarnishes. Your silverware, you usually keep it in a chest or a drawer, and it's lined with that cloth that looks kind of like felt, and it keeps it from tarnishing. All right. Jewelry silver, that's the other alloy we're going to talk about. Jewelry silver. Jewelry silver is composed of 80% silver and 20% copper. Okay? How much pure silver should you mix with 15 ounces of jewelry silver to make sterling silver? Okay, so there's the problem. Now let's think about what we're doing. I have jewelry silver, right? How much do I have? 15 ounces. Okay? I want to make sterling silver out of it. So I got it in a pot right here. It's 80% silver, 20% copper. If I want to make sterling silver, I want it to be more silver. Okay? So I've got to dilute it down with silver, right? I want the silver percentage to go up, the copper percentage will go down. Is it because I'm taking copper out of it? No, it's because I'm adding stuff to it. It's going to dilute the copper down some. You see what I'm saying? How else could I put a problem? Not talking about an alloy. How else could I do the problem? Gasoline. Okay? I could say, yeah, or like chlorine. You got not enough chlorine in your pool, right? What do? You add chlorine to it, right? How much do I add to it to get my percent chlorine up to right here? You see what I'm saying? Punch. Is punch the same thing? Okay, it says add a quart of ice cream. All I got a gallon of ice cream. How much more ginger ale do I need to add so that my percent of ginger ale and ice cream is the same as what I originally wanted it to be in the recipe? You see what I'm saying? All those things are the same kind of thing. Those are all the different ways that you could look at the same kind of problem. Okay, so this is how you work this problem. Now y'all listen, this problem is kind of hard to understand, okay? So, oh, thank you, Spencer. No, Spencer's going to write something on the board.
I thought they fixed the problem.
No, they didn't fix the problem. They gave me something that will work, but when I use it, I have to unplug my mic. So, and when I'm recording, I can't use it. All right, and I don't like it, so I'm not switching to it. All right, so here we go. What I want to do is here's what you're deciding. I'm going to make sterling silver, so I know I'm either going to work with this 92.5% or I'm going to work with the 7.5. Why? Because that's what I'm trying to make. Does everybody understand that? Okay, so which one of these numbers will not change? Will the percentage, now look what I have, okay, the copper won't change, right? Because we're not adding copper to it, and we're not taking copper out of it, okay? So that's how I choose which one to work with. Does everybody understand that? Whichever one, you're not adding that to it, that's not going to change. So I'm going to use 7.5 out of what? 100. 7.5 out of 100. Now, someone said, hey, Miss Davis, could I have written that as .075? Yeah, you can. But guess what? I'm making a proportion, and you know how to solve a proportion, right? It's going to cross multiply. So, this is how much copper is in the solution that I want, okay? It should be the same as the copper in the solution that I'm making. Does everybody understand? Okay? All right, so let's talk about what we're making. Now, there's some words in here that we ought to know what they mean. First of all, when they say how much, that's actually my variable, right? So what do you want to call it? X? Okay, so how much? That's X. How much pure silver should you mix? I don't really like that word mix. What are we really doing? Adding it. I changed it. I marked it out in my notes, and I put, I don't like mix. We're adding it. Okay? We're going to add it to 15 ounces of jewelry silver to make sterling silver. Okay, so how much copper do I... Now remember, this is what I have. Okay? It's not what I want. I'm trying to make what I want, but this is what I got. So what's the percent of copper in what I have?
1 over 5.
No, give me, it's a number. We're not making a fraction out of it. Give me 20%. So we're going to call it a decimal. What is 20% as a decimal? 0.2. Could I put 0.20? I'm going to put 0.20. Why am I writing 0.20? That's exactly right. Because some kids will look at that 0.2 and they won't know where I got it. But if they look at that 0.20, they'll go, oh, she got it right there. That's 20%. Yeah, move your decimal point 2 places to the left. Okay? 20% of what? Of how much? 20% of how much do I? 15 ounces. Okay? How much copper do I have? 20% of 15 ounces. Okay? Now look what I'm doing. Part to the whole. Everybody agree with that? Part to the whole. All right. Now, I had 15 ounces, but what did I do? You adding. How much did I add? What did you call it? So this must be 15 plus X. Does that make sense?
No.
Okay? Part to the whole, part to the whole. Didn't make sense?
It's the second part that's confusing.
This part is confusing, but y'all listen to me. Every time, this is what you're going to do. Whatever you're working with over here, you're going to take what percent of what I got. Okay? Look, this is it. This is what you're trying to make. This is what I got. What do you have? 20% copper out of 15 ounces. So I multiply those on the top. Out of, what's the whole thing? Well, I have 15, but I added X amount of pure silver to it, so now I have 15 plus X. Okay? Can I solve this, guys? Y'all, this is easy to solve. Okay? I'm going to cross multiply. The first thing I'm going to do is say, what's 20% of 5? What's 1/5 of 5? Of 15, pardon me. 20% of 15. 3. It's 1/5 of 15 is 3. Okay? So that is really a 3 right there. So what's 100 times 3? 300. Equals. Now I'm going to multiply this. 7.5 times 15 plus X. Alright? Probably going to need me a little calculator. What's 7.5 times 15?
112.5.
112.5. Perfect. What's 7.5 times X? 7.5X. I'm solving for X, guys. Tell me what to do. Minus 112.5 from both sides. This will give me 187.5 is equal to 7.5X. Now what am I going to do? And X is equal to how many ounces of pure silver did I have to add to my jewelry silver to make sterling silver? 25 ounces. Okay, so what are you going to do tonight? You're going to go home. Y'all, this is an example. You have your book at home. You're going to work this how many times? 3 times. The first time you work it, you're going to start out, you're going to have to look back at this. Okay? The second time you work it, you might have to look back. The third time you work it, you should not have to look back. And then, I mean, you know, if you wanted to do more, I would go back here. Do you think they have a word problem back here in their word problem section like that? I don't know. But guess what? I have one on my worksheet that I'm going to give you tomorrow. So if they don't have one, I'll give you another one. Okay? You'll have it on that worksheet. All right. No, I didn't see one. You just work this one 3 times, and then tomorrow I'll give you a worksheet, and it'll have another one like it. Okay? And I just lack just a couple more things that I want to work with you, and then I'll give you the rest of the time tomorrow to work on the worksheet. And then Thursday, I won't see you, and then Friday, I'll teach something else. If I don't get finished with it on Friday, I'll finish it on Monday. If I do get finished with it, I'll give you Monday to review and work on your worksheet, and we'll test Tuesday and Wednesday. Okay? Is that better? All right.
Well, we started, because I was tomorrow,